Okay, back for round two of parabola examples. So we've got parabola, at least we think it's parabola anyway, second degree quadratic equation, two variables, x is equal to 1/2 y squared. So first thoughts, as we're asked to graph this and identify all these crazy things about the parabola, is we need to determine, is this an x squared or a y squared parabola? Is it an up or down parabola, or is it a left or right parabola? Well, I notice there's a y squared term and x is just raised to the first power. So that tells me this guy matches the green one, a y squared parabola. So that thing is going to open either to the right or to the left. Now, I notice that this is positive. Even though it's not on the right side, or the correct side, I should say, it's still positive, and I got a y squared. So that's telling me that this guy is definitely going to be opening to the right. Okay, positive y squared parabola is open to the right. Now, the next thing I'm going to do is I'm going to put this in standard form and get the square by itself on one side. So if I want y squared by itself, I would have to divide by 1/2. Well, it's easier to multiply by the reciprocal, which is 2. So if I multiply both sides by 2, y squared is going to equal 2x. So y squared, right or left, positive, definitely right. So make a little note. Vertex is 0, 0 again because I haven't changed anything. I haven't translated the function at all. We'll get into that soon. But for now, we're assuming the vertex is going to be at 0, 0. And it's going to open to the right. So if you want to do a quick little sketch like, hey, it's going to look like that, it certainly doesn't hurt. Okay. Now, finding P, the focal length, is the next big deal that we got to figure out. Well, remember, when it's in standard form, y squared by itself, that's nice. The expression 4 times p must equal whatever the number is that I see there. Well, it happens to be a 2. So I do a little bit of algebra thinking, and I set 2 equal to 4 times p, because then I can solve for p by dividing both sides by 4. Well, 2 divided by 4 is the same as 1/2. So p is equal to 1/2. P, my focal length, is 1/2. So that's how far I need to go from the vertex to the focus. So if my vertex is 0, 0, and this parabola opens to the right, I need to go to the right 1/2 unit to get to the focus. So from the vertex, I'm going to go 1/2 unit to the right, which puts me right about there. Okay. Now, let's label that point. Well, the first part of my xy coordinate pair would tell me x is if did I go right or left. Well, from the origin, I'm 1/2 unit to the right. So the x value of that point is 1/2. The y value of that point, well, we didn't go up or down at all. We're still on the x-axis, so that must be 0. So my focus is at 1/2 comma 0. That's that point right there. My directrix then, I'm going to go 1/2 the focal length, but in the other direction. So if I went 1/2 to the right to get to the focus, I'm going to go 1/2 to the left to get to where the directrix is. Now remember, the directrix is going to be a line, and that line is going to be perpendicular to the axis of symmetry. Okay, the axis of symmetry would cut the parabola in half. If the parabola opens to the right, the axis of symmetry would look something like this. Okay, I'm not going to draw it so I don't confuse you. But the directrix is going to be perpendicular to that. So let's think about how I would label that. Well, a vertical line, which is what the directrix is in this case, is always going to be x is equal to something. So what is the x value of every point that's on this line? Well, because I went 1/2 unit to the left from the origin, negative 1/2 must be the x value of all of the points that are on this vertical line. Okay. Last thing to figure out would be the focal width, or the latus rectum. Now remember, you find that by taking the absolute value of 4 times p, which is the focal length. Now, a smart person would say, well, if I already had 4p is equal to 2 up here, wouldn't that make sense? And I wouldn't have to actually multiply by p? Of course, that would be a great thing to think. For those of you who don't understand what I just said, we're going to take 4 times p, which is 1/2, and that's going to be 2, absolute value of which is also 2. So 2 is going to be my focal width. So what that means is, like in the previous example, if I were to draw a chord that passed through the focus and was parallel to the directrix and perpendicular to the axis, the length of that chord would be 2. So I'm going to go draw, like imagine a chord. I'm not going to connect these, but if I did, the length of that segment would be 2. So these points are definitely going to be on the parabola itself. So with that, I'm not going to get rid of the thing that was in blue. Okay, I'll put my vertex back. And I'm going to then draw my parabola based on what the latus rectum happens to be. So there's my curve. You know, it's okay. Maybe it could be a little bit wider, but that's not terrible. So it opens to the right. It's got a focal length of 1/2, which means in this case go 1/2 to the right to get to the focus, and go 1/2 to the left to get to the directrix. And it's got a focal width of 2, so that's how wide the parabola is in relation to where the focus happens to be. So hopefully that enlightens you a little bit better with how to identify all these different pieces of parabolas. So good luck on the online assignment, and we'll talk more about this stuff in class.